Welcome to the instructional video for 1.4. Just going to highlight on some of the things that we go through in 1.4. And what we're talking about in 1.4 is the inverse. So if we describe f of x as the function, then the way that we would write the inverse of that function is it's f, kind of like it has an exponent of -1 of x. And I'm just going to put that this is the inverse of f of x. What is really important is that students understand that f -1 of x does not mean 1 over f of x. That is the reciprocal. It's something we touch on in 20-1 math, and we will see it again in 30-1 as well. Okay, let's do the mapping next, because I think that is the next easiest one, is if I look at f of x and having any point on that graph as x comma y, then when I look at where that point goes to on the inverse, then all that happens is the y and the x change. Now, looking at a specific point, if I had 6 comma -7 on the inverse, I would have -7 comma 6. And it's important to approach the mapping as that direct and simple and straightforward. For the visual, what's happening when we take that inverse is I'm going to draw the original function. So f of x is going to be in blue. And we'll certainly unpack this a bit in the notes as well. So the blue graph is f of x. What the inverse is doing visually is if I draw this green dotted line, that is the y equals x line. What the inverse does, and I'm going to exploit my smartboard just a little bit here, is it takes the original function and it rotates it effectively or reflects it around that y equals x line. Now, I didn't draw these very well, but that's okay. They actually should intersect along the green line. When we actually do this in the notes, we will use a bit better. I'm just going to tweak it so it works. That green line is where the invariant points would occur. And the invariant points, always an important discussion in this course, my invariant points for the inverse are going to be anywhere that x equals y or y is equal to x. Those are the same thing. You don't really need to write both. Okay, let me change the color on this, and then I'll label it. We are going to make that maybe just red, and that would be the inverse of my function. So that graph in red would be f -1 of x, or the inverse of f of x. Okay, there's one other thing that comes up in 1.4, which is something called the horizontal line test. And it basically is telling us the horizontal line test is drawn on the function, not on the inverse. And if it passes, which is to say it hits the graph in only one location, then f -1 of x is a function. So I'm going to show you two here. Just extend the page a little bit, that I'll draw the parabola that we just looked at. So I'll do that. The color doesn't really matter. So just a bit of a narrower parabola. And then we'll look at, let's look at maybe a very, very simple one, like just a straight line. There we go. Took me a while to think of that. Now, if we do the horizontal line test, what we need is a horizontal line. And again, I'm cheating a little bit on the smartboard, but both of these graphs would be, independent of each other, functions. If I took this green line and I put it on my red parabola, we see pretty clearly that it hits that red parabola in two different spots. Now, if I draw the inverse of that red parabola, just like above, it would look something like this. And we can, I hope, very clearly see that my inverse is not a function. It fails the vertical line test, almost everywhere. Whereas for my straight line, the black graph over here, if I took my, oops, I didn't mean to do that. If I took my horizontal line and I shifted it on it, we would see that it only ever hits that black linear function in one location. Now, the reason that that is also, the reason, that tells us that the inverse of the black line would be a function. And those are really, really powerful things because they allow us to quickly identify, whether we could draft this in our calculator with one equation, or when you get to the examples, you'll actually see that a lot of these harder inverses require multiple equations to make our calculator do them. Okay, that's the instructional piece. Make sure you do keep going, watch those examples, and attempt the homework, please.